Now you understood this one. What is the difference between a sample and a population? So randomly I'm going to pick a person and I'm going to ask a question. Pujita, can you tell me what a population is? Pujita? Hope you people have understood, right? What population, what sample is?
Yeah.
Yes, sir.
Yes, sir.
Can the please tell me what a population is? What is a population? What do you understand by
Collection of
population?
items.
Yeah.
The total number of items taking into measurement for our interests.
Yeah. So first thing comes is what comes? First comes is the study. So we are doing a study. For if we don't have a study, we never have to collect the data or we don't have to do any analysis. So first thing is our study. We have some study to do. That's the reason we are going to do statistical analysis. And whatever the items that you're going to collect for doing that study is called as population. And what is sample? What is a sample?
A subset of the population.
Okay, why we consider samples or populations? What is the reason?
To analyze and statistically.
Pardon?
Use the data to statistically.
No, why we consider samples or population? What is the reason?
Population hard, easy to define, like that. Easy
Pardon?
after some experience. It is cheap, right? If you
Yeah,
go
it is.
population, it's hard to define. If you go
Yeah,
sample, it is cheap and faster.
yeah, exactly. So it becomes faster, it is cheap, it saves our resources, right? So that is the reason we go with samples. Okay, good. So now you have understood what a population is and what a sample is. Now you are very free to choose your own categories that should come into the population. Now your brains are free. Now you understood what category should I consider as a population? Should I define as a population before starting the study, right? And what are how I'm going to select my samples? All these things will be understanding very easily now. Now your minds are free to select, and now you are wise enough to understand what is a sample, whether the sample that I'm going to collect will be representative of the population or not, right? So now we'll move ahead to data classification, because without data, or whatever the items that you're going to collect, it will be in the form of data. Am I right? So you're going to basically analyze your data in statistics. So without understanding the data, we cannot proceed further. Without understanding the data, we cannot proceed further. So here we are going to look at different data types or the classifications of the data in statistics. So data, how the data is classified here? Data is classified into two subsets. First one is categorical, second one is numerical. So what is categorical?
Mostly text data.
Category. It could be product ID. To say.
So here, if you see, we have two types of data. One is a categorical data, another one is numerical data. When I say category, so it should be other than numbers. So what do you mean by other than numbers? So even my row numbers are also numbers. Even so let us say the numbers of employees. There are some employee IDs. They are only numbers. Let us say they are also numbers.
Can't measurable
No.
like that.
When you are able to perform an operation, a mathematical operation, then it becomes number. When you get a result.
So which gives a meaningful result for us, right, Niti? So whatever gives a meaningful thing, let us say if I perform an average value on employee ID column, what I'm going to get? Am I going to get anything important information from that?
No.
I have employee ID number and I'm going to apply, let us say some aggregate function, let us say maximum, minimum of the employee ID number column or minimum of employee ID number column, or if I'm going to apply average to that column, if I'm going to apply, let us say, any other mathematical function, will it give any meaning to us? It is only
No,
an
sir.
ID. It is only an ID that is representing a person. In the name of Gurucharan, some name is given. In the name of Kamil, some other number is given. In the name of Niti, some other number is given. Right? That's it. In the name of Balu, some other number is given. It's alias. So it is also a category. It's also a category. Simple, nothing but category. So what is the basic difference between a number and a categorical data? Even if you have numbers in the categorical data, if you're not able to get any meaningful conclusion when you apply some aggregate functions or any mathematical functions, then it is also a categorical data. And those numbers which are in categorical data, those are called as pseudo columns or pseudo values, whatever you want to say. Right? So now let us see the examples of categorical data. So if you see here, categorical data represents categories or groups, just simple groups. We have social groups, we have Facebook groups, and even in Facebook also we have different groups, right? Indians in Paris, Indians in Sweden, Indians in blah 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 blah. There are different groups like that. Music people, one group. So likewise, if you see here, we have different categories. Okay, what are the categories? Like we have car brands, we have all Mercedes cars as symbol, one group, all BMWs are one group, Audi cars one group, and then you have next yes or no questions. Here we have only text value. See, do you have a car? Do you have a house? No. Do you have a car? Yes. Are you enrolled in the university? No. So there is no number involved in this one. Everywhere you have category. Right? When you come to the numerical data, what is going to happen? See here, we have again two subsets over here. One is discrete and other one is continuous. What do you mean by discrete? And what do you mean by continuous? Continuous, can you please tell me what is the meaning, basic English definition? What is the English definition or meaning of discrete or continuous in your own?
Discrete, it will not change. Continuous, it will change. Way it will change, right? Day by day, it will increase or decrease like that. In discrete, it will not. I think so.
Exact value.
Basically, discrete means what exactly it means in English. You know what exactly?
Exact value.
exact value, that is fine. But have you ever heard in the chemistry or some other things like discrete units?
Like a
Have you
fixed
something discrete means when you say it is the smallest unit, basically. There cannot be, if you go to even calculus, we say that what do you say, like in calculus, for example, say the smallest value that is available, or whatever the thing after dividing, whatever the smallest thing that can be possible, it is discrete. And continuous is which is continuously changing. There is link between the numbers, or the link that is going to change, that is tend to continue. Correct or wrong? Continuous means, what does it say? There is no break. Correct or wrong? There is no break. What do you mean by continuous? Continuous is without break. Discrete means there are breaks. How there are breaks? There are breaks in the form of, let us say, now if you want to say how many children you want to have, I would say 1 or 2 or 3 or 4. Of course, you cannot, you'll never say that I want to, you cannot say that 2.5 or 2.8 or 2.9. Can you express in the form of decimal values? Can you do that? No, right?
No, sir.
Yeah. So that is a whole number.
I have one doubt.
Yeah.
Can we call population number is a continuous value?
Population number. No, don't go there. Who is this?
Jitendra.
Jitendra, we cannot say population number as a continuous number. See, one thing. When we get this values like numbers, when you are going into the data in the population, right? You are never speaking of the entire population number or the count as continuous or discrete. Now, for example, I'm going to give you, okay, because you're getting confused, I'm going to take an example of real-time data so that you'll understand it very clearly. Okay, I'll take the same example that we have considered, and I hope you have seen these values. Okay, now you have this data. Is everybody able to see my screen on the sample
Yeah.
store
Yes, sir.
data? Yeah, see here, I have data here. Now you tell me, this is all categorical data, right? Whatever we have over here, let us say, I'll put some format to this one so that it'll be easily understanding this one. Let us say I'll put it somewhere in this one. Okay, so now if you come here, these are my headers, right? These are my column names, and this is all my data, right? Now if you come here, I'll say whatever you are seeing in this way. You see here, till here we have all categorical data. See here, everything is text. See, now I have postal code. These are all numbers only here. I have only numbers. But why I am calling this one as categorical data? I have row IDs. Why I'm calling this one as categorical data? If I am going to apply some mean function or average function on this one, or any min max function or count function, what does it give for me? It doesn't give any.
There is no meaning.
There is no meaning, right? It doesn't give any meaning to me. So that is the reason we call them as categorical data. But if you, on the other hand, always you remember in the categorical data always will be in the beginning in any data set, usually, right? Usually this is the trend, and you'll find all the numerical data at the last. See here like this. So this is numerical data. Now we have sales values, we have quantities, we have discounts, and we have profits. So here if you see, we can represent these decimal values also as discrete values. Of course, they can also be represented as discrete values. Quantities we have 2, 3, 4, 5, 7. They can also be represented as continuous values, of course. Then what is the difference between continuous and discrete? What is the difference? So we are considering, when we are considering this one as a unit, unique value, then this can be considered as categorical data. I mean to say this can be considered as discrete values. But when you want to put this data in the form of continuous values, you can put it in the form of continuous values, because my sales is going on increasing. It is decreasing.
Can you repeat it again, please?
Yeah. So what do you mean by discrete? Discrete means we can differentiate, Jitendra, from one quantity to other quantity. Now take these two values. Can I take these two values as discrete values? Yes or no? Because the values are 261.96 and 731.94.
Sure.
They are different values. So these are discrete values also. We can differentiate, right, between these two numbers.
Yeah.
So when you represent on the graph in the form of, let us say, bar chart, or let us say you want to differentiate, we want to take them as discrete values and represent them. If you want to represent the frequency of this value in this particular data set, I can take this one as discrete values.
Okay.
Correct or wrong?
So if we are defining the frequency, then it is a continuous value. Frequency is a continuous, because we never know that it may be increasing in the future value.
Now let us say, for example, your height or weight. How do you say weight? Weight, you are eating some food, your weight has increased. Right? Weight has increased, and then you went for jogging. You have lost some weight because of sweat. Correct or wrong?
Yeah.
So it is continuously changing. We don't know whether that value, it cannot remain constant.
Okay.
You understood?
Yeah.
So
Yeah.
that value, height or weight, it is continuously changing. It is in point something, some value, 0.85798, which you are not able to measure. It may be that we don't know that decimal values. How we are going to measure that is a different concept. But anyway, it is changing, right? It is continuous.
So in my terms, population growth also kind of continuous, because the population will be continuously growing or decreasing.
Exactly. Of course,
It won't
that's
be
what
constant.
yes, if you want to consider as continuous, you consider it as continuous. Of course, population is changing, so that is continuous. Correct. So if you say my discrete values, again, if you want to say that discrete, now if you come to discrete values, if you want to consider each member of the population, if you want to put on the graph and you want to find the frequency, so they can also be considered as discrete.
How?
Now, for example, now you see here what's happening here. Now I have my discrete values. These are all differentiable values. I have some unique values right here. I have whatever I have sales values. There are some values that are repeating inside these values. There are some values which are repeating. I want to say 261.96, which can be repeating. Let us say inside this data set, if it is repeating, for example, I'm telling it is not exactly it is repeating or not. So let us say it is repeating for 5 times. Some other value is repeating for 4 times. Some other value is repeating for 5 times. Likewise, there is some frequency. I can take that discrete, I can take that value to represent on a graph as discrete value, right or wrong?
Yeah.
But at the same time, sales can be considered as continuous value also. How? Because sales can increase or decrease. 261.96 will be tomorrow. It will be in the next minute. It will be 261 point something else.
Yeah.
Correct? No. So it is up to you. It is up to your wiseness, or it is up to your discretion how you are going to consider the value.
Got it. Excuse me, sir. I have a doubt. How did you say sales was discrete, sir? It will keep changing.
That's what. If you say this 261.96 is there, right? 261. If you in one case, if you want to say 261.96, if I want to find the frequency of the numbers over here which are present over here, let us say 261.96 is existing for 5 times. Let us say, what will you say? If I want to say, if you want to represent on the bar chart, how would you say? I would represent 261.96 on one value, on one bar, and I will say this is existing for 5 times in my data set. Yeah. It is differentiated from this value to other value, right? This value is differentiated. But this can also be made as continuous when you are telling that, okay, my sales is now it is if you put the same sales values onto the line graph, if you are putting months on the x-axis and sales on the y-axis, and if I put a line graph, this is a continuous value or not? Sales is a continuous value or not, Niti? Tell me.
It is continuous, sir, but I do not understand how it will fall under discrete, because it can be a different category depending on subcategory and it repeats.
No, when I'm going to consider only this one 261.96 as a value, this is a unique value, and this unique value, it is existing for, let us say, 10 times over here. It has happened for 10 times. When I'm representing on the bar chart, this, how do you represent 261.96? This is a discrete value, right? This is a unique value.
Yes. Yes. Okay. Got it.
Now you understood?
Yes, sir. I understood.
So it is up to your wiseness how you want to change your data, how you want to understand the data. That's what your mind should be free. How you should differentiate the data, how you want to consider the data, how you want to represent the data. Is that fine to all of you?
Yeah, thanks.
Yes, sir.
Yes, sir.
That's what is very important.
In discrete, we can only integer numbers only. In continuous integers as well as fraction numbers, right, sir?
పూర్ణిమ ఇప్పుడు ఎట్లుందంటే మనము కంటిన్యూస్ డిస్క్రీట్ అని ఎప్పుడు అనుకుంటాం, మనం అనుకునే కేసును బట్టి మారుతుంది అనమాట. అది ఇప్పుడు
డిపెండ్స్ ఆన్ సిచ్యువేషన్స్.
ఇప్పుడు సపోజ్ మనము ఒక 261.96 అన్నది ఒక వాల్యూ ఉంది, అది 10 సార్లు ఉంది నా డేటా సెట్ లో. ఇప్పుడు నేను ఫ్రీక్వెన్సీ కనుక్కోవాలి. ఫ్రీక్వెన్సీ ప్రతిదాన్ని రిప్రజెంట్ చేయాలి. ఈ 261.96 10 సార్లు వస్తుందా, లేదంటే 731.94 ఒకసారి ఎన్నిసార్లు వస్తుందో కనుక్కోవాలంటే ప్రతి వాల్యూని నేను ఈ డేటా సెట్ లో యూనిక్ వాల్యూస్ అన్ని తీసుకొని దాని ఫ్రీక్వెన్సీ వేసేసి దాన్ని నేను బార్ చార్ట్ కింద పెడితే ఇవన్నీ డిస్క్రీట్ వాల్యూస్ అయిపోయినాయి కదా నాకు. అదే నేను సపోజ్ ఇదే సేల్స్ వాల్యూస్ ని నేను ఎక్స్ యాక్సిస్ పైన మంత్స్ ని పెట్టేసి జనవరి, ఫిబ్రవరి, మార్చ్, ఏప్రిల్ ని పెట్టేసి 2015 ఇయర్ కి, అండ్ వై యాక్సిస్ పైన సేల్స్ ని ప్లాట్ చేసాను అనుకో, లైన్ గ్రాఫ్ పెట్టేసి, కంటిన్యూస్ వాల్యూస్ అయినాయా లేదా? మరి సేమ్ డేటానే, కానీ దాన్ని డిస్క్రీట్ అని అనుకుంటున్నాను ఒక కేసులో, ఇంకో కేసులో నేను కంటిన్యూస్ గా రిప్రజెంట్ చేస్తాను.
ఓకే
సో అది మన పైన అనమాట, కేసు టు కేసు మనం ఆలోచన చేయాలి. ఆ డేటాను మనం ఎలా డిఫరెన్షియేట్ చేస్తున్నామా లేదా అన్నది ఇంపార్టెంట్. డిస్క్రీట్ కంటిన్యూస్ అన్నది ఏంటంటే మీనింగ్ ఏంటంటే మనము discrete is always differentiable from one category to from one value to other value, it is differentiable. But here when you say continuous, we are not differentiating it. It is a continuous curve like normal distribution. When you say normal distribution, what it is happening, any value can be possible from 1 to 100 అని నేను ఒక్కసారి చెప్పానంటే రేంజ్, ఆ రేంజ్ లో నా శాంపుల్ డేటా సెట్ లో స్టూడెంట్స్ 1 నంబర్ 0 నుంచి 100 దాకా ఏమైనా స్కోర్ చేసుకోవచ్చు. దాంట్లో ఆ స్కోర్ కూడా ఎట్లా వస్తుందంటే నాకు 1.1 1.1.1.167 అట్లా ఉందనుకో సపోజ్ నంబరు, కంటిన్యూస్ వాల్యూ, ఇన్ఫైనైట్ వాల్యూస్ ఉన్నాయి. 0 నుంచి 100 లోపల ఇన్ఫైనైట్ వాల్యూస్ ఉన్నాయి. అవన్నీ కంటిన్యూస్ నంబర్స్. అదంతా ఒక నార్మల్ డిస్ట్రిబ్యూషన్ కర్వ్ ఫామ్ చేయొచ్చు. సో ఆ శాంపుల్ డేటా సెట్ లో నుంచి ఏదన్నా ఒక నంబర్ పాసిబుల్. దట్ ఈస్ వాట్ ఈస్ ప్రాబబిలిటీ. అది అక్కడి నుంచి డీల్ అవుతుంది అనమాట. సో మనం ఎప్పుడైతే డిస్క్రీట్ వాల్యూస్ అని అనుకుంటామో దాన్ని అది కంటిన్యూస్ కాదు. అప్పుడు ఎప్పుడైతే కంటిన్యూస్ అనుకుంటామో అది డిస్క్రీట్ కాదు. సరేనా? సో దాట్స్ వాట్ అబౌట్ discrete and continuous. So remember in that way.
Thank you, sir.
Yeah, discrete is constant and continuous is changing. Yes, you are right, Lavanya. Discrete is constant, it is not going to change. Exactly, this is what I wanted also to say, Lavanya. So when you are considering when you consider that value as discrete, it is going to remain constant in that study. If you are going to say continuous, it can change. Correct, Lavanya, you are right. Hope everybody is clear with the concept. Balu, Radhika. So it is our perception finally, right? Please understand this concept. Now we'll move ahead. So here if you see, we are giving the examples of discrete and continuous values. So if you see here, we are able to differentiate between the numbers, discrete, right? If you see here, discrete data usually is counted in finite numbers. Usually there is a word that is used, usually, to be counted in finite number. A good example would be number of children you would want to have, even if you don't want, even if you don't know how many you want to have, right? So what is important for the variable is to be defined as discrete is that you can imagine each member of the data set. Now, as I told you, usually it will be represented as a finite number, but it is not mandatory. But will you ever go and say that? Will you ever go meaningfully? Meelo evaraina sare ee data set lo nunchi will you ever go and say that? Why will you ever meaningfully go and say, any one of you tell me 261.96? Will you go and count how many times it is existing? It is foolishness, right? You will never do that. 261.96 అన్నది ఒక ర్యాండమ్ నంబర్, అది సేల్స్ నంబర్. అది ఎన్నిసార్లు ఎగ్జిస్ట్ అవుతుందని కనుక్కుంటే మనకేమొస్తుంది? ఏం రాదు. కానీ at the same time, if you represent the sales data as a continuous data, then we will get some meaningful results. How the trend is changing, how the sales values are changing. Correct or wrong?
Yeah, true.
Correct, right? Why would you go and say why 261.96 is existing for 10 number of times or 11? I am not interested in finding that. I am very much interested in finding the trend of sales, how the sales is changing with the time. So that is the reason we call these values are continuous. In quantities, there I am very much interested to see I want to know how many 2 quantity customers are there, how many 10 quantity customers are there who have purchased 10 quantities of that product, 5 quantities of that product, right? Correct or wrong? Why would I say, why would I bother even if I like this value? Of course, this can be one meaningful thing, how the quantity is changing over time. That can also be one meaningful thing. But here, why would I say this 261.96 is existing for 10 times or 11 times? That is of no use for me. I would definitely like to know how the sales is changing with time. Like this month, how much it was, and next month, how much it is going to be. So there, this will be continuous values. There, quantity will be discrete values. Correct or wrong?
Correct.
Correct. So that's how you should discrete. You should have that discretion in your mind. So you should be able to. You should be wise enough to understand the data and to tell, yes, this is what is the thing that we should understand. Meaningfully, whatever you do it meaningfully. Right now, I think you have understood the difference between the continuous data. So continuous data, on the contrary, is the infinite and impossible to count. For example, height, weight, which can take every value in the in that range which I was telling you, right? It can take any other range. Right? So that was about our continuous and discrete data. So now I'll go to measurement levels. So we have seen now the basic definitions of samples, and we have seen basic definitions of basic things of data, like data classifications, categorical, numerical, and now we are going to look at measurement levels. So what are the measurement levels that we have? We have qualitative and quantitative. Okay. So as a term, so quantitative says that it is representing quantitative variables, and qualitative, it is representing categorical variables. Okay. So when you come to qualitative, you remember in that way, we have qualitative and quantitative. So when you remember quantitative, the opposite one is qualitative. Quantitative one is again subdivided into interval and ratio, and qualitative one is again subdivided into nominal and ordinal. Okay. So when you come further, if you see here, when you say nominal, so they are different categories, like we have Mercedes-Benz, BMW, Audi cars, seasons like winter season, rainy season, summer season, right? These kind of seasons, their order is not at all important for us. Now those kind of things are called as nominal measurement levels. When you consider ordinal measurement levels, there the order of the categories is very, very, very important. Now let us say, for example, you are going to rate a pizza that you have tasted, right? You have tasted a pizza, let us say in the Pizza Hut or in Domino's, whatever it is, don't bother. But you want to rate the taste of the pizza. These are the categories. You want to put those tastes. You want to classify the taste as distinguishing, unappetizing, neutral, tasty, and delicious. Distinguishing, unappetizing, neutral, tasty, and delicious. Now this set is called as ordinal set. Why we got the word ordinal? Order means the terms or the words, they should be in an order. The categories itself, they should be in an order. Here if you see, it starts from a negative word, extreme negative, towards extreme positive. We are passing through a neutral word also in between. See here, distinguishing, disgusting. Disgusting means it is the worst. Unappetizing, it is not. It is better than, of course, it is a negative word, but it is better than disgusting. And then you have neutral. You're saying that it is neither good nor bad. and then you are telling that tasty. Tasty, that means okay, it is good, okay, it is so, or it is good, you can say. And we are saying delicious, then it says that okay, it is very good. So the order of this sequence, I mean the sequence of these categories is very important. So that is the reason we call it as ordinal measurement levels, right? And then we have quantitative variables, which can be divided into both ratio, which can be divided into either ratio or intervals. So what is ratio? So when you take an example of length, right? For example, length we have. So when you say 0 centimeters, when you say 0 millimeters, and when you say 0 centimeters or 0 kilometers, the length, it says that it is 0, right? It says that there is no length, right? Those kind of values or those kind of variables, they come into what? Into ratio measurement levels. They will be classified as ratio measurement levels. And where you say 80° Fahrenheit, it doesn't say that 0, because it is referring to the, it is taking the base scale of some other scale. It is referring to the Kelvin scale, right? It is not absolute one. It doesn't have absolute 0. So when you refer it to the absolute 0, let us say 0° Kelvin, from there if you refer something, then it would be a ratio. Otherwise it will be called as interval. It will be classified into interval measurement levels. I hope this one is clear to all of you. Any doubt?
No, sir. Okay.
Good. So now we are going to stop here and just will take a small revision over here. So we have started with the definitions of sample and population. So what is a sample? Sample is nothing but the collection of items of interest to a study. So that is what is important. We should keep a study as an important factor over here. Without study, we don't have the collection of items. So what is a population? It is a collection of items of our interest to our study, right? And it is always represented by capital N, and the numbers that we obtain using population are called as parameters. And what is a sample? Sample is a subset of population and it's always denoted by small n. And the numbers that we obtain are called as, while working with samples, the numbers that we obtain, they are called as statistics, right? We have seen this example to get a good understanding on population and sample. So finally, to say populations are very hard to define and observe because they are very time consuming and they need a lot of resources. That is the reason we go with sample collections, because it is easier to contact, it consumes less time and it is less costly, right? And then you have sample. Mainly sample should be random and representative, right? And then we have seen different types of data, which is categorical data and numerical data, where we have numerical data is again subdivided into discrete and continuous. So continuous, we categories will have only categories, like different categories of cars, like yes or no questions, likewise. And then we have numerical data. Numerical data we have discrete and continuous, where usually the discrete data is represented in the form of finite numbers, whereas continuous data will be continuous. It can take any value that is possible between that range, in that infinite number range. So that is called as continuous number. Examples are height and weight, right? And then we have seen measurement levels, qualitative and quantitative. So here Again, they are subdivided into nominal, ordinal, interval, and ratio. Nominal is different categories where the order of the categories is not important in the ordinal, but order of the categories is important. And in quantitative, we have ratio and interval. Ratio, when you say ratio, when you say example, taking the example, when you are seeing 0 centimeters, 0 millimeters, or 0 inches, 0 kilometers, everything means that length is 0. So they have some base reference from where they are being calculated. So that is, those kind of variables are called as or classified as ratio measurement levels. And then you have interval. In the interval, we have where there is a reference to it, like an example of temperature. If you say 10 degrees Celsius, we cannot call it as a ratio. It should be in the interval range, because the reference is, the absolute scale is Kelvin scale. If you refer if you refer a temperature from Kelvin scale, it would be absolute one, it will fall into ratio. But when you say 0 degrees Fahrenheit, 10 degrees Fahrenheit, it is again something else in the absolute scale. That is the reason we call them as, or we classify them as, interval measurement levels, right? So this is what is the gist of today's discussion. Now